Okay, we're going to be going over the scale factor today. Okay, scale factor of similar figures. So we went over similar triangles today, and today again we're going to focus on triangles. There's a little formula here. We're going to talk about that second. Shouldn't have put it at the top, but I just want to refresh your memories with this. We have our two triangles, and these both are similar triangles, we're going to say. Okay, so these angles, angle A and angle X are the same, angle B and Y are the same, and angle C and Z are the same. If you guys recall, the way we name the sides of a triangle, we just put the lowercase letter opposite of that angle. So this is side A, that's side B, this is side C. And the same with our X, Y, and Z. Okay, so we've named this triangle. And there's a ratio. We focused on this part of the ratio yesterday, where if we take side A and divide it by side X, that's also the equivalent of side B divided by side Y, which is also the equivalent of C divided by side Z. Okay? Let's say I actually gave them some values. And this will be a similar triangle. This will be, shoot, I want to make it a real triangle. So let's go with 3, 4, 5. Okay? And this is going to be 9, 12, and 15. Okay? So with that being said, we're going to put these scale factors up here. Our side A, we said, was 9. So 9 divided by X, X was 3, is equal to B, which is 15, divided by Y, which is 5, is equal to C, which is 12, divided by Z, which is 4. What is 9 divided by 3? 15 divided by 3? 12 divided by 4. Okay. I should have said 15 divided by 5. This is considered your scale factor. So when we were doing that ratio yesterday, when you divided all of those terms, you should have got the same number if you were to actually divide them all. The scale factor K is the number 3. Okay? K stands for our scale factor. This is very important. Okay? Now, we've already done this yesterday. We just didn't call it anything, so that's really simple. The only thing I want to add to that today is area. So, area of triangle ABC. So, the area of this triangle, which is the base times the height multiplied by a half, okay? So, triangle, or area of this triangle, is equal to the area of the smaller triangle, base times height times a half, if we take the scale factor between them and square it, and multiply it by the smaller triangles, okay? So this little formula is just going to help us with the area. There aren't too many questions on it, but we got to remember this part of it. So if I take this area, and then I square the scale factor and multiply the two, it will give me the area of the bigger triangle, the bigger similar triangle, okay? So, first thing we want to do here is, this is a river, this question. They want us to find how wide the river is. What I want us to do is actually find the areas of these triangles, okay? We're going to find the areas of both of these triangles in this question. Well, the very first thing we need to do is I have the base, or actually let's talk about the smaller one, triangle SBA. We have a base of a triangle and we have a height, okay? And the reason I can call those the base and height is because I know this is 90 degrees. How do I know this is 90 degrees?
It's a right angle.
We don't know for sure it's a right angle. What in this, using our angle properties, helps us? It has a what? This thing I just drew in? Okay, let's assume that wasn't there before I drew it in, because as you notice, it's about to disappear. It's not actually there. Chris?
It's perpendicular to the river.
Doesn't technically say that anywhere. Anyone know their angle property rules? Simon? Okay, and what does this make? You guys remember this rule? It looks like it makes a Z. You guys, would you remember? Anyone remember what that rule is called? Oh, you guys didn't have the actual mathematical name for it? Okay, well, we'll call it the Z pattern for you. If you notice, this creates a Z, okay? This is parallel, and this is parallel, which means that this angle here and this angle here must be the same. So, since I know this one is 90 degrees, therefore this one must be 90 degrees also. So, since that's 90 degrees, I have the base of this triangle, I have the height of this triangle. I can find the area very simply, but in the other triangle, I have a base, 24. I don't know what the height is. The height of it is essentially going to be the width of this river, the original part of this question. So we're going to have to use our scale factors to solve this. So let's go ahead and name this triangle. If this is S, this is side S. This would be side B, and this would be side A. If this is M, this is M. Now I notice this is B, there are two B's. So we're going to call this B1, and this side will be B2. Okay? And finally, that's W. This will be side W. So let's set up our ratio here. Side S corresponds to what side of the larger triangle? And I'll highlight the two triangles in case you aren't able to see them. Okay. This is our bigger triangle. And this is the smaller triangle. Okay. I know, very difficult. So, side S corresponds to what side of the larger triangle? M, that's right. So S divided by M is equal to what? Let's say I use the next one being side B. Oh, good. Yeah, right. I wrote that as base. That is side A. Whoops. That's side A. This is B1. So if I write that as side A, what is the corresponding side in the larger triangle to side A? W, that's right. These two sides are corresponding to each other. And then of B1, what's the corresponding side in the other one? B2. Okay. You guys understand that idea? They named this point just B, so I called one of them B1 and one B2. We don't want to be solving for the same variable. They're not technically the same length. Let's write in the information we have. Side S, we don't know. Side M, we don't know. So we have S over M is equal to A being 9.3 divided by W, which is 24. Okay? And B1 is 8.4, and we're looking for B2. Okay? We don't know what B2 is in this case. So we need to find that B2. We're going to focus on just these two ratios because this one has no information, and they're both the hypotenuse of the triangle. We don't really need that right now. Okay? So what would be a fast way, because the variable we're looking for is on the bottom of the fraction, what is a fast way to get rid of the fraction to get the variable on top? Good. We're going to cross multiply. So we cross multiply these two. I get 9.3 times B2 is equal to 24 times 8.4. So 8.4. 8.4 times 24. 201.6. 201.6. Great. How do I get B2 by itself? We got to divide by our 9.3 on this side. So side B2 will be equal to, we take this value and divide it by 9.3, 21.67. 21.67. Great. So we found the width of the river, 21.67 meters long, which will help us find the area because now I have a base and a height. But let's say for some reason I wasn't able to do it that way, or I want to solve the area very quickly. I could have referred to the original formula. So if you guys notice right now, I now have enough information to just plug them both in to find the areas for both. Let's say for some reason I didn't think of it that way. Let's use this formula to actually find it. We were able to find the scale factor. Anyone know how to find the scale factor? What is K in this case? What two numbers do we have to deal with? Find our scale factor. How do we find scale factor? You guys look up above. What did we have to do with these numbers? We divide them. Do we have one complete ratio here? We don't? What is it? That's right. This is a complete ratio. If we divide those two, we're going to have a scale factor of K. Okay? So there's several ways we could do this. We'll take the 9.3 and divide it by 24. That's 25. 9.3 divide 24. 0.3875. 0.3875. That is our scale factor. Okay, we've just discovered the scale factor. So, since we know the scale factor now, we can use that formula from above. And I'm going to write it down here. The area of the larger triangle. Right? Area. And the larger triangle in this case is called BWM, so area, that should be an A, of triangle BWM is equal to the area of the smaller triangle, which was known as SAB, I think, SBA, times the scale factor squared. Well, we know our scale factor is 3875. Okay, we know that's a scale factor. And we can actually find the area of the smaller triangle because we have the base and the height, if you guys notice. We have base and height, so let's actually find the area of the smaller triangle. I can find this area right here. Area of triangle SBA is equal to the base, which was 9.3, times the height, which in this case was 8.4. Base times height times 1/2. As base times height gives us a rectangle, and a triangle is half of that rectangle, so we multiply by 1/2. So the area of the smaller triangle, 9.3 times 8.4 times 0.5 equals 39.06. Great. 39.06. Okay. We have 39.06 as a smaller one. This is our scale factor. So in order to find the area of the larger triangle BWM, we find the area of the small one, which was 39.06. Okay, that was the area of the small triangle. We discovered it here, so we plugged it in. And then we square our scale factor here, right? That's going to be our K. 0.3875 squared here. Okay, so remember just a second ago we stopped where we thought we had the area, but I said there was an error in the question. That's because of the scale factor we've used. We used the smaller triangle, and this was our B. I think this was M, and that was a W, right? If you guys notice, what we used here, S, I think this was side B, and this was side A, okay? We used the smaller triangle on top of our ratio, so that was the smaller triangle going towards the bigger triangle. We did division like that. We took all the small triangle sides, that was our S, our B, and our A, and we divided them by the larger triangle, which was M. I hope this is right. I think it was W here. It was the other way around. This was M. Oh yeah, there's B1 and B2, right? B2. Okay, that's that. Okay. Regardless, the point we're trying to make here is we took the smaller triangle, and what this ratio is when we put the smaller triangle on top, this is a ratio of going from a smaller triangle to a bigger triangle. So we can multiply any of these sides by our scale factor K. Okay? I think I said that backwards. We're going from the bigger triangle to the smaller one. We can multiply any of these sides by the scale factor K and get the smaller triangle. Okay? So I reverse these arrows. Let's fix that. If you notice, the scale factor is less than 1, which makes sense. Anytime we multiply by something less than 1, we'll be shrinking in size. So the scale factor we got, we can look at the scale factor and tell, are we going from the big triangle to the small one, or from the small triangle to the big triangle? In this case, we're going from the big triangle to the small triangle because this is a number less than 1. Well, what if I'd set up the ratio the other way? I didn't say that there was one way you had to do it. Remember, we said yesterday whether you put the bottom on top or the top on bottom. So what if we set up the scale ratio with M divided by S is equal to B2 divided by B1, which is equal to W over A. And we plug those values in. Well, the main value we would have got was 24 divided by 9.3. That's how we found the scale factor the first time, right? We had two values here, but we used this to find the scale factor the first time. If I set the triangle up the other way and divide it, and we divided 24 divided by 9.3, 24 by 9.3, 2.58. In this case, our scale factor k would have been 2.58. Okay? Well, which one's right? Both of them are technically right. And what they are is reciprocals of each other. Okay? And what I'm trying to tell you is, if I were to take the first scale factor, they're both reciprocals of each other. So if I took the scale factor 3875, and I took 1 and divided by that, I would get 2.58. Or, if I were to take 1 divided by 2.58, I would get 0.3875. Okay? Both are scale factors, but each of them represent going from a different triangle to the other. So this guy represents going from the large triangle to the smaller triangle. This guy represents going from the smaller triangle to the larger triangle. All we have to do is take one of the values, multiply by the scale factor, and we'll have our unknown side. And we can do the same thing. We would take a value, multiply by a scale factor, and we have the other unknown side. One will shrink the triangle, the other will expand it. So with our area formula, we had plugged in the wrong scale factor. We needed to use 2.58. Okay? And what we've done at the bottom, we've already kind of gone through this. We fixed our scale factor. This was not the one we should have used, because we were going from the smaller triangle to the larger triangle in this case. So we should have put in this scale factor, 2.58, plug that into the area formula, and that would have solved it. And we went above and we checked with our previous information. We used the height and the width, and when we put that into the area formula, we got 260 meters squared, was exactly what we found before.